Well. We have our third and last speaker of the day. This is Bram. He's from AnalyzeData. He's going to be talking to us about real-time SIP fraud detection and prevention, something that every single person on here, I'm sure, has dealt with. So without any further ado, Bram, are you here?
Yes, I'm here. Then I suggest I start. So thank you, Alex, for the introduction. So welcome, everyone. My name is Bram. I'm a co-founder of AnalyzeData, where we develop anti-fraud solutions for various applications. And in this presentation, we show you how we actually use OpenSIPS to enable the real-time prevention and detection of SIP fraud. But before we continue with the presentation, there are a few announcements to be made. So in this presentation, we give you a live demo of our fraud detection platform, and we've also installed a honeypot. So for those of you who are interested, you can go to the following IP address on the slide, where you can basically use your own soft phone and start dialing numbers to the platform. Then during the live demo, we can see what kind of traffic has been generated and what we can do further on. So don't worry, the slides and the IP addresses are also shared on the Slack and on the YouTube channel, so that you can also look up this information afterwards. In order for the calls to be considered valid, they have to be specified in E164 format. So in addition, we've also organized a poll where we were really curious to see how the OpenSIPS community is currently suffering from the SIP fraud. We're really wondering what your experience is in this area. So we've actually created a slide for you that's also accessible via the QR code, where you can actually share your experience. And what you will also notice in the presentation are these green boxes, which are references to the questions that we've also put in the survey. For those of you who fill out the poll by the entirety, we also offer you a free fraud detection on a data source of choice. But more about that later on in the presentation. So yeah, I don't have to tell you guys that SIP fraud is a huge issue in this world. And so on average, the financial damage per telco provider per month is estimated at 25K. And we at AnalyzeData believe that this number is simply too big. And we need, our mission, in fact, is to reduce this fraud back to 100 euros. And you may be wondering what our current progress is this far. So far, we managed to reduce 80% of the fraud compared to existing industrial anti-SIP solutions. So the presentation will consist of 3 parts. At first, I will tell you about the technology that we have developed during my PhD in cybersecurity that actually forms the foundation of this anti-fraud platform. After that, Rick Broers, also a familiar face in OpenSIPS, he will also going to tell you how we implemented the OpenSIPS sensor to actually enable the real-time detection of SIP fraud. After which, Josh will present the results and the use case that we presented, we did a showcase at Destiny, and he will also give the live demo. So during my PhD at Eindhoven University of Technology, my job was to develop new techniques to discover next-generation computer viruses. And so current antivirus software either generated too many false alarms, or they were simply unable to capture these viruses. So I started digging into server logs and into raw network traffic to spot unusual behavior. And there we somehow discovered a way to represent data in such a way that these outliers are spotted instantly. And this enables us to actually go through the data very quickly to find the true problem in there, so that we know exactly which kind of machine learning techniques to use in order to detect the problem automatically. So it turned out that the techniques that we developed did not limit themselves to security, but also could be applied to other domains. So at first, we applied the techniques for the analysis of SIP traffic coming from and to PBXs, where we discovered that there were hackers already trying to get inside the system weeks before the actual fraudulent calls were happening, simply by actually looking for disturbing patterns in the SIP signaling. Another completely different scenario was, for instance, organized by the IEEE, which is the largest affiliation in computer science that organizes events where they basically ask industry and the rest of the world for feedback on a certain data set. So in this case, we received a data set from a wildlife preserve where we actually, where we had to figure out why certain animals were dying. And one of the observations that we discovered was that there was at some stage a truck driving through areas in the park for which he was not allowed to, and eventually responsible for the dumping of chemical waste. The interesting thing about this challenge, however, was that on average, it took teams from six people from industry from all over the world 3 months to discover what has been going on in this data set. And we used with our tooling, and we solved the challenge in just a few hours. So that was really a wake-up call. We had something very interesting in here. So we also applied the system at the university, where we started to study the network traffic. And there we discovered that there were certain users being a victim of ransomware, because we saw some high disturbing patterns in their in the file access behavior of these users. So luckily, we reported these things back to the university, and they were able to stop the encryption from further escalating. And so you can imagine that these kind of things are very valuable. So we also applied the system, for instance, in healthcare, where we started to analyze patient treatments to see how we can optimize the workflow in the department of a hospital. And so you can imagine these patients, they were diagnosed with cancer. And in fact, we discovered a group of people who did not receive certain treatments that causes their recovery time to be 3 times longer than it actually should have been. And especially for improving healthcare, these are very vital observations. So you can imagine that these results did not go unnoticed. And we've won several awards in different areas, but also were invited to present these results at very prestigious events, including Black Hat USA and also Still Hacking Anyway. So in addition, we were also invited so every year to share our recent developments in fraud detection in international reports, such as the European Cybersecurity Perspectives. So for those of you who are interested in the articles, I've made some shared links on the slides, which we'll also make available after the presentation. And so the thing was that we applied the fraud detection techniques in many different domains, but we noticed that especially in SIP, the need for anti-fraud solutions was simply by far the most. So that's why we decided to focus in this area. If you would already open up the Europol reports, then you can see that the financial damage estimated last year was already in the billions of euros, indicating the seriousness of the problem. And we're not the only one who've been talking about this topic. Also, Flavio, one of the OpenSIPS pioneers, already gave a talk at Astricon where he already indicated the value and need for anti-fraud solutions in SIP. So how is it then that we do things differently? So basically, so many traditional anti-fraud solutions, they focus on the analysis of call detail records. But there are several disadvantages to the approach. At first, CDR records are all generated after a call has been made. So even though you can detect that a call is fraudulent, then basically you're already too late. The money is already gone. And in addition, the only way that you can actually prevent the fraud from happening is by blocking that entire user, which also means that the regular traffic of this user becomes impossible until after investigation. So we actually discovered that in many cases, the fraud could actually already be discovered at a very early stage during the establishment of the call. So that's why we decided to AnalyzeData to analyze the full life cycle of a call using SIP analysis by studying the SIP signaling packets. So, and there we actually are able to, even when we already discover that a call is fraudulent, we can already early stage block the call to prevent the fraud from escalating. And in addition, you do not have to block any users anymore because we can, on a call level, on a per call basis, decide which ones are the bad ones and which ones are the good ones, so that the user can always stay online. And so we have already developed quite a number of modules to support a wide range of SIP fraud, including Mengerink and also international revenue sharing. And it is because of our core technology developed at the university that we were able to very quickly develop new modules in case of very domain-specific fraud or upcoming fraud. So we also use, and so the reports that the incidents that we report are coming from different types of severities, and we use advanced clustering techniques to make sure that these incidents are only reported once. So the thing is that because we know exactly which type of machine learning techniques to use, that our false positive rates are very low. So typically, we generate one false alarm every 2.5 million calls, which is roughly 100 times better currently than industry standards. So how does the system basically work? And so we have a SIP traffic that is being captured by OpenSIPS and is being sent into events that can be analyzed by AnalyzeData. And besides OpenSIPS, we also provide support for other types of SDKs, common for instance for PHP and JavaScript. So the incidents can be inspected via a front-end interface, but alternatively, you can also decide to receive them by text messaging, mailing, Slack, or generic webhooks. So the moment these incidents arrive at the operator, he can decide indeed whether these incidents are indeed fraudulent, after which the information is returned to AnalyzeData so that we know how to adjust our models to prevent false alarms from happening. So basically, there are different types of ways to integrate with the system. So one of the more common approaches in an out-of-line solution is by mirroring your SIP traffic through the OpenSIP sensor that in turn uses a REST API to forward the events to AnalyzeData. And so AnalyzeData in turn can then generate the alerts and send them to the operator, after which he can decide what to do next. If you want to enable, for instance, the live blocking of calls, there is also a synchronous solution, and where the events are also sent via a REST API, but are guaranteed to return within a certain amount of latency, so that the OpenSIPS sensor can then in turn decide whether to forward the call or to return it back to the call source. And so although that these first two integration steps are fairly generic, there's even another way that we can do in SIP to make it even more efficient. And that's by configuring AnalyzeData as another SIP endpoint. So basically, this way of integration is simply adding an entry to your routing table, which means that the SIP the traffic is first routed to AnalyzeData, after which we can perform the analysis. And then if we consider the fraud to be fraudulent, we return a 603. That in turn can be routed back to the call source, or we can use a 503 to indicate whether a call is normal. After which then the OpenSIPS as a soft switch knows that it has to route the traffic to the next destination. So the nice thing about this way of integrating is that you do not have to mirror your traffic, which can be very expensive. And you also do not have to install any probes, but we can simply, by adding an entry in your routing table, make sure that your traffic gets directly and as efficiently as possible to the sensor. So this was my part of the presentation. Rick will now continue on the development of the OpenSIPS sensor and the showcase that we used at Destiny.
Good afternoon, everyone. So yeah, I'm going to tell you about what we exactly did with OpenSIPS in this setup with AnalyzeData. I was on the Destiny side of things, of configuring, seeing how the first version of it would work and function. We put a lot of calls through it. So what did our setup look like? We already have an IDS in place, traditional IDS based on CDRs. Next to that, all of our, to start with, all of our traffic is, of our SIP traffic is basically within a VMware. So within VMware, you have the possibility to easily mirror your traffic to separate nodes, which meant that we had to install on every of our VMware machines, we had to install a probe. But first, obviously, we started with one, and that already came into some problems. And I think Bogdan and Livio both had some contributions to fixing it. But okay, back to our use case. OpenSIPS was in the mirror setup. It basically receives all of the invites, all of the SIP traffic being mirrored from our VMware environment. And from there on out is being put over a HTTP connection towards AnalyzeData, HTTPS even, because we don't want anyone listening in on our traffic, obviously. From there on out, we went to compare the results between AnalyzeData hits and our own hits based on IDS. I think you've found nearly all of the fraud that our IDS also found. I think you found all of the fraud even that our ADS found. But more on that later. So regarding the OpenSIPS, how does it work inside the OpenSIPS? At the moment we were testing that there were two versions. We had, I think, a freshly released 3.0 at the time, and 2.4.6, which was more of the main branch at that point. I don't know if you've already switched to 3.0 as your main branch at that point. But we tried both. Why did we try both? Because in both we came across a different bug, which made that we couldn't continue any further. What did we try to do? We got all of the traffic on an OpenSIPS, which was basically listening on an open Ethernet port on its VM, and SIP capture module, which enables OpenSIPS to listen in promiscuous mode, so it can read all the traffic. So every invite which was sent into the machine was then being able to be processed by OpenSIPS, which in turn allowed us to extract all of the information from the invites, ACKs, cancels, all of the messages you want to inspect, and throw it over to AnalyzeData over the REST interface. And then at the end of the script processing, we simply drop the message, because obviously as we are in promiscuous, we don't want to respond to any kind of message. So to get that to work, I think we first tried it on version 2.4.6. And well, this is some snippet from, yeah, we really load a minimum set of modules. I hope it's all readable, it should be. And this is basically the main body of the script that we've been using. You can see there's 3 dots here, obviously indicating that there's more of the same. So we're checking for a method, and from then on out, we're going to build together a JSON packet with all of the parameters which we are interested in, or of which AnalyzeData is interested in. And at the end, we do a REST pose towards their endpoint with the JSON, and we wait for the reply on, which we can then report on in the logs or something. Put a simple xlog, and then you can see what the response is of AnalyzeData. So on 3.0, what happened on version 3.0? We had, I think, a bug which hit immediately as soon as the first packet would arrive on the interface. It was related to the SIP capture module. And I think Bogdan fixed it in about 10 to 12 days. But the other issue, which we had on 2.4.6, I think was even fixed earlier by, I'm not sure if it was Razvan or Liviu, one of the two. But he saved the day by fixing a bug in the REST client, where we also had a crash. Yeah, as you can see in its sync, I'm not that much of a developer myself, but yeah, it had something to do with initializing something, which didn't happen in this case because we were running one of the unique cases, such as Bogdan mentioned in his first presentation. So yeah, we found both of these bugs. We reported them both, and they were both fixed, I think, within 10 days. So that was a very good experience. And eventually we went on with the 2.4.6 branch because that was that had the quickest response, and we could also fix it ourselves. We did a small little patch on the code. Yeah, and then it's my time to turn over the mic towards my colleague, Josh Mengerink, who is going to also give us a small demo. So if you have a small minute, then he'll be ready for you. Thank you very much.
Yeah. So let's see if I have, you didn't mute it, did you? No, it's still muted. So good afternoon. Yeah, it's still afternoon. So my name is Josh, and I'm one of the co-founders here at AnalyzeData, mostly responsible for development and engineering. So yeah, to get back to what Rick said about the results that we did. So comparing our results of this sensor and using our machine learning and AI techniques to analyze the SIP traffic in response to the traditional IDS used at our pilot customer, we found that we block 92% less call minutes invalidly. So this is calls that get blocked due to some rule-based intrusion detection system that should not have been blocked. So imagine a conference call, 20 people call in, and there's a large amount of cash going into that call, but it's a legitimate call. And a rule-based approach would immediately invalidate that call, whereas our machine learning is able to actually circumvent that. And also, in addition to the regular IDS that was also already in place, we managed to find 80% more fraud, so saving quite a lot of money for the company. So our biggest achievement there was that we actually found a hack that the real IDS only spotted 3 months later. So we were in an out-of-line solution, and at some point they said, oh, hey, why was this not signaled this month? Yeah, because it was already signaled 3 months ago. So that was really one of our biggest achievements. So the nice thing in this use case is that we were able to reduce the average damage of a fraud case to 6 cents rather than thousands of euros, which it is normally. So that was a great achievement, really. So let me, because that's what I'm here for, let me give you a quick demo of what we've been doing. So I wanted to see, so there's 2 things I'm going to be demoing to you. So one of the things, as Bram already mentioned, is that we set up a honeypot this weekend to just see, like, hey, how cool is it if we can actually do a live demo? So let's hope that the demo effect does not kick in and it all works. So I'm first going to be showing you some of the results that we got just over this weekend, just over the amount of random hacks. I think we set up our honeypot, and I think it took all of 10 minutes before we started getting spammed with fake registers and fake invites. So that was quite, I thought they were quite fast at that. And secondly, just to make sure that we actually show you some interesting stuff, we'll be going into one of our existing demo projects that already has been pre-populated with some data. So let's see about the honeypot. So what we see here is a quick overview of incidents. So what are incidents? Incidents are basically clusters of calls that we mark as fraudulent. So if a call comes in, we can mark it either as safe or fraudulent. And if there are a lot of calls that are highly similar, we group them together in an incident to make sure that it's understandable. So up top here, you see how heavy the incidents are over time. So this is yesterday when we spun up our honeypot, and you see there are apparently almost 5,000 fake registers fired towards that honeypot. So this allows for zooming. There's not really a lot to zoom. We'll see a little bit of that in a bit. So let's just get right into it here. So here we have a bunch of incidents that have been reported by our platform. You see at what moment in time did the hack attempt start? At what moment was it did we detect the last event in this incident? What was the estimated amount of fraud that we think we could have countered in this sense?
I think we are not seeing your screen.
You're not seeing the entire screen, or?
We're stuck on a screen with the demo.
Sorry? You're still seeing the slides. Okay.
Yeah.
Let's see if I can reshare. Share my entire screen. This one, share. Okay, hang on. I think this is going to be bad again. Is this better?
Yes. Yep.
So now you should have two windows, one saying demo 2019 and one saying OpenSIPS demo.
Right.
You're on.
Yeah, all right, awesome. All right, so quickly to recap, because you had the voiceover, two demos, the OpenSIPS demo of the honeypot that we've had up this weekend, and then let's actually dive into some actual data. So is my cursor visible, by the way? If I'm getting feedback from you guys anyway?
It is.
Okay, great. That's awesome. And now I can't see you guys anymore, so that's kind of shitty. There you are. All right, so again, incidents. So here you see a number of incidents that our platform has detected from a particular user. Right now, because we don't really have usernames or stuff in this fake online environment, we're just using IP source combination. IP port combinations. You see the number of calls that we've grouped into that incident, the severity. So we work with a traffic light signal where it's either green, yellow, or red. Then you can see what sources are involved. Most of our platform, well, pretty much all of our platform, and also the honeypot works in an anonymized setting. So that's why you're not seeing entire numbers, but anonymized numbers. So here you see that it's like pretty fake stuff, like 4-digit numbers, 1111, 2222, 333, etc.
Sorry to interrupt. If that's a web interface, maybe you can increase the font a bit. It
Sure.
will help.
This better for you?
Yeah. Okay.
Okay,
Yeah,
so it's going to be smaller. Let me see. Is this still acceptable? Because if I go too small, it'll start going into tablet and mobile mode, and then we're going to drop columns.
It's acceptable at this stage.
Okay, good. I can try. I'll explain a little bit, and I'll zoom in so it's a bit bigger even still. So it'll tell you just something about the incident, and then I guess really the most interesting stuff is what's happening in the back. So we're giving like a short summary of why do we think that this is actually an incident of fraudulent calls. So in this case, one of our algorithms has suggested that this is potential bot activity. So what you're usually going to see is a large spike in activity rather than just some regular normal curvature like real large spikes. We'll see that in a bit as well. And we've also detected that these are not actual phone numbers being dialed. So in this case, 1111 is not a valid source number. And you see that most of this is probably most likely the same attacker, because like all of these numbers and all of these incidents are the same. So let's open one up and let's see what we do. And I can probably zoom a little bit more for you guys. So up top is the summary of what have we analyzed. So as Dick was already saying, there's a bunch of stuff that we receive from OpenSIPS. So there's message IDs, there's display names from URIs. So all of this stuff should be pretty familiar to you guys. So yeah, so here indeed we see that this is a friendly scanner, which makes a lot of sense, right? So it's a scanner and then just scanning, well, pretty much like on what ports are we open at all. So yeah, that makes sense that we have such a large amount of similar activity going on. We get a summary of how far did the call go. So in this case, they're just pumping registers to us. So the call does not advance. Normally here you would see actually the stages of the call going from registered to trying to answer to buy, all this kind of stuff we'll see in a little bit. And this call, or this packet, was marked by our AI as being suspicious. And then below, we'll see this in a little bit more detail in the second part. We'll actually have an explanation of the different algorithms, because we use a large variety of why our algorithms actually triggered this as being fraudulent. Now, for all this, all these registers, it's not that interesting. It's mostly large spikes in activity and invalid numbers, and you'll see that it's the same for all of them. So let's, to make it interesting, go to actually some of our pre-populated data to actually see some more interesting stuff. And you'll see that probably now, because we're streaming, the demo effect's going to take effect and my internet's going to crash. So there it is. So here you see a 4-month period of time over which we've done fraud analysis. It reaches from January to like April, and you have the intensity, like at what point in time did you receive how many alerts from our platform. So this helps admins just focus and zoom in on particular parts. So here you see, for example, that week 13 was a particularly high activity week with almost 3,000 fraudulent calls. And we estimate that this is almost 4,000 euros worth in damage in this week alone. So once we have this stuff, again, here you see a little bit more variety of the different types of algorithms that we use. So again, bot activity, high amounts of premium number dialing, stuff like you're dialing countries that you're normally not dialing, you're dialing at weird moments in time, all of this kind of stuff. So let me just open up really the first major one.
If I may push a question here.
Yeah,
okay, you say your algorithm identified like a potentially dangerous destination or a potentially, let's say, wrong time of day. Do you pre-configure this? Do you have kind of a profile saying, okay,
yes,
for this caller, you know, this time window, it's the okay one or not, or which are the, you know, the allowed, or
yeah. So let me open up
triggering destinations or stuff like that.
Yeah, so let me open up this activity, and I think that'll immediately answer your question. I'll scroll straight down. And so one of our activities, or one of our algorithms, indeed analyzes what time is it normal for this user to be active, right? And so this makes a lot of sense. This looks a lot like a business phone. Like they start dialing at 7 o'clock in the morning, and they probably end at like 6, 7 o'clock at night, 5 days a week, and not on the weekends, right? This makes a lot of sense. This is kind of like expected behavior. And as you're saying here, we have a profile of like what is the expected activity for this user that we've learned. And for this particular call, it's a Tuesday night at 10:15 in the evening. And you see, like, this is so unlikely. Like, this person never calls in the evenings, and all of a sudden they're calling in the evenings. Moreover, it's not like they're just calling in the evenings. Here we see the number of calls this user is making that we've marked as fraudulent before, right? So we see enormous spikes over the past couple of days of this user doing suspicious stuff, right? So that makes other calls that are already a little bit suspicious more suspicious because they're happening in large clusters. And actually, your second question was with respect to countries and destinations. So let me quickly, I have to zoom out a little bit now. Let me find actually a very interesting user with respect to countries. I'll zoom in a little bit again. To cooperate, yes. So the data again that we're analyzing here is very faint, right? So we have a time, at what time was the call active, was the call done, from what was the source number of the call, what was the destination of the number of the call. Again, our algorithms function even under anonymization, which is really cool. So you can probably really quickly see how this information can be extracted already at an invite, like a register invite stage. And here you see these dispositions that I was talking about earlier. So at some point in time, this call was trying. Already 2 seconds later, it was answered. And this was so quickly on. This is something that we also analyze. So you see that over time, our traffic light signal may actually change. So the simple fact that a call is answered might already make it more suspicious. The speed at which a call is answered might make it more suspicious. So your question was with respect to profiling of call destinations. So here we see the profile of this user of their call destinations. And well, since we're doing it semi-interactively now, Bogdan, so how about you tell me whether you can see something suspicious in this graph?
Well, besides the color over there.
Yeah, exactly.
Like,
right.
So what you are saying that in terms of destination and also, let's say, time pattern, everything it's like learned data.
Yes.
There is nothing pre-configured.
No.
You just give a time your software to gather and crunch data and say, okay, that should be the user profile in terms where and when it calls.
Well, yeah, so actually we do both. So there's a couple of, how do you say, there are a couple of things about SIP signaling that are at some point so blatant that it's so easy to say, yeah, this is just plain wrong. Like at some point, if you have a user and they fire 100,000 failed registers for a user ID, and then attempt 100,001 is successful. Yeah, we don't have to learn anything. Like that's a brute force. We're seeing immediately that's a brute force. We're blocking it. But so in this case, indeed, it's learned. Like if you see this is a user, we're a Netherlands-based company, so you see that the Netherlands traffic, this is pretty much like 99% of what they're doing. So if we like disable this regular behavior, we immediately see, all right, there's something really suspicious going on here. Like at some point, this guy for months and months on end, they're just dialing Dutch numbers, and all of a sudden they're dialing God knows how many numbers. I don't know, who knows how many destinations. Oh, and I think I zoomed a little bit too much there. So I need to reset. So actually, if you zoom into this particular case a little bit more detail, you'll see that this actually takes place into like 3 or 4 hours. So the probability that they're just always only calling the Netherlands and like matching their volume in 2 hours to like God knows how many destinations, our algorithms determine that that's super unlikely. So
just quick for you, if I may. How do you determine those activity cycles? Are you using like some kind of FFT transfer, or what is the
I'm sorry, I didn't quite get your question. Sorry.
I mean, for the activity cycles of the user, is it something that your system learns?
So this, you mean these graphs? Like, yeah. So this is something that we actually learn over time. So we have a learning period of approximately 2 weeks, and then we use a variety of machine learning algorithms to actually determine like what is part of your regular behavior and what is not. If that answers your question.
Yeah, it is.
Yeah, right.
There is also a question about from Oliver. He asks to point to the website. I don't know. Apparently, somebody could not find your website.
The URL for AnalyzeData.
Oh, it's AnalyzeData.com, but with a Z.
Just like in the presentation header, guys.
Yes, exactly. If that's not working, then it's probably because you're DOSing it. No, just kidding, just kidding. So yeah, it's like after this presentation, if you guys have any further questions, just like please just jot them down and we'll get back to you in the Slack. But also feel free to like just keep them coming. Like we're very comfortable answering stuff inline. So with respect to this call graph, like visualization is a big part of what we do, trying to just make it easy for operators to determine like, is this fraud? Is this not fraud? And if it's not fraud, to feed it back into our machine learning algorithms so that we can make our decision making even better. So here you see it quite regularly, like pretty much all of their frequency, dark blue, is centered on the Netherlands. And so there's a bunch of really weird traffic going on to all sorts of places. Like normally we'll see that there's a source will call stuff that's in the vicinity, right? Like a US-based number will call mostly North and South America. An EU-based number will call mostly mainland Europe, et cetera, et cetera. So already stuff that goes beyond borders is beyond continental borders is really weird. So this is quite a blatant one where it's just all over the place. Let's see, what else can we?
There was a quick question here. The profiling, is it only user-based?
So actually, our profiling is configurable. So you can do profiling on a caller level. You can do profiling on a server level. You can do profiling on a trunk level. So it's really configurable. You tell us on what level you want us to profile the stuff. We can also do all of it or none of it, of course, but preferably some of it. But yeah, so it's configurable. And so in this use case, we are working on the trunk level. So every trunk, so every customer that is actually porting stuff into our OpenSIPS platform, we're profiling per customer, basically. So that's why you'll probably see some differences. So let's see if I can actually show that to you. So again, as said, so here you will see a user that has a very nice 5 working days. There might also be users where you'll see less high peaks, but they go on for 7 days, which is then clearly really like a consumer phone. You'll see different types of behavioral clusters, let's call it that way. So one of the things that we are working on currently is actually, can we cluster users into different types of users, like business phones, consumer phones, real trunks, and that type of stuff. So I guess that's pretty much all I have to show you. I mean, we can do more examples if you guys like that, or we can just open it up for questions.
We have some questions that were kind of like lagged on here. Does it, you know, on the SIP level, are you guys analyzing things like transferred calls as well?
So I'm not that big of the SIP guru. I must. Do you guys have audio? You guys don't have audio, probably, right? All right. So can you repose your question and then I'll fire it into the group here?
The question was, does the at the SIP layer, is it tracking or including analysis on transferred calls?
So the question is, on the SIP layer, do we include transferred calls? So if I understand your question correctly, I'm going to try and answer. Maybe these guys can point out some errors on my side. So transferring is if, when you have a multi-leg call. That's your question, I guess, right? Or is that
pretty much?
Yeah. So we have some infrastructure in place that will actually try to correlate if you have multi-leg calls and you're not giving us a proper correlation yourself, that we actually try and correlate different phases of the call. At a current stage, this is best effort, because sometimes with concurrency, this is really hard to do. I guess that pretty much covers it, right? Yeah.
Yeah, in the OpenSIPS level, you have the invite, which is being sent into your platform, and a transfer mainly also works with invite, re-invites. There's some different mechanisms, but I mainly think these are used.
Yeah, exactly.
So you have basically all of them.
Yeah, exactly.
And you correlate them then probably together.
Yes, yes. So in this use case, it's really nice because they already have a correlation mechanism in place where they will, if they transfer the call, they will give you the call ID of the previous call that they're transferring. So we're able to like as like breadcrumbs, like it's a breadcrumb trail, and we're able to reverse engineer the breadcrumb trail. But yeah, so we do that partially, yes.
I have a question regarding the you mentioned some detection algorithms. Are those already hard-coded? Is there some sort of language that can be used to define your own, let's say, detection algorithm?
So at present, we have only, well, hard-coded is a bit of an overstatement maybe. We have predefined analyzers, yes. So we have approximately 25 algorithms and you can choose which ones yes or no you want. So some of them are privacy technically more intrusive than others. So for example, you might not want to give us the countries, right? The source and destination countries. So you might want to give us geo coordinates or not. So depending on the types of additional metadata that you give us, we're able to do better or worse types of algorithms in terms of detection. Our platform is configured in such a way that it should be doable to add user-defined anomaly detection. So at present, all of our algorithms have these learning parameters, but they're also user configurable. So there is, in that sense, nothing that would stop you if, for example, you want to define a threshold-based rule, you can define that. So it's not out of the box yet, but it is supported in the backend infrastructure, yes.
I have a question.
Yes. There's so many different places, and it's hard to keep track of who's asking questions. Please.
Hello, Vasilios. So I saw in the previous slides, what is the average latency response for the inline solution?
So it varies. So to answer your question, it depends on how many services you have active. So if you want our full suite of analyses, you're looking at between 150 to 200 milliseconds. If you want an optimal set, so there's a couple of ones that take really long. And if you exclude those, then we are usually sub 100. So the baseline set is actually at like between 30 and 40 ms. And if you start including more heavy profilers, so if you want like a 60-70% catch rate, then you're looking at this 50 ms range. If you want to go up to 80%, then you're looking at a 100 ms. If you want to go beyond 80% catch rate, like to 90-95, then you're looking at 150 to 200.
So if we limit it on per destination, for example, and let's say 90%, so it's low as a kind.
You have a lot of echo. I'm having quite a hard time to understand your question. I'm sorry. Could you repeat?
So if we limit by destination only, for example, that would be lower, right?
Yes, yes. So indeed, like you could tailor the stream that you feed us so that you don't want all algorithms. It's even in that sense possible that you do a multi-staged approach in which we do a preliminary analysis where you say, for example, okay, I want a risk score based on only a couple of algorithms. And if this one says, okay, like 100% safe, fine, let it pass. If it's not 100% safe, say you get like a preliminary threat score of say 50%, yeah, then you might choose to incur another 100 MS and do another round trip with a more heavy check.
Okay, and another one, do you support importing CDRs?
Yes, yes.
So your platform can learn quickly?
Yes, so that is an excellent question. So indeed, so that is like the main difference that I failed to mention to you guys. So this OpenSIPS demo is like live right now. It's coming from an OpenSIPS that's running right now. And this demo is actually imported from CDRs. So what is happening in the back of our stuff is that what we're trying to do with this live OpenSIPS integration is we're partially emulating the CDR. So as CDR information becomes available to us, we're augmenting it in our database and rerunning the analysis on that augmented CDR. So you can imagine that, for example, in a completed call, so it's not included in this example, for example, the billing information, which is a really good indicator of how fraudulent is a call. It's not available to you like as the call is being set up, but it is available to you usually after termination. So in that sense, like once that information becomes available in our virtual CDR, we're able to go back and feed that back into a machine learning algorithm.
Okay, thank you.
Great.
I have a few. Can I ask a few questions of you?
Yeah, sure. Like I think Bogdan is keeping track of time, right? So,
you handle the presentation. Don't you worry about it.
Shoot.
So, first of all, why are you using SIP mirroring and not app protocol for SIP capturing as it was meant for those purposes? Why are you want to mirroring the SIP traffic and not just get the app to do the asynchronical analyzing?
So the question, I'm going to forward this to you probably. So the question is, why are we using? Sorry.
Yeah, just to drop in a bit, because I was about to ask more or less the same question. There are two different things. So first, from the, let's say, from the actual, when you are not inline mode for the actual platform, you do mirror the full SIP to the OpenSIPS, which extracts data, and then you do the REST query. And I think Shlomi's question is, why do you use this kind of a custom REST query, which extracts kind of a metadata from the SIP package in order to send it to the AnalyzeData, when you could also use the existing HAP protocol to get these metadata from OpenSIPS to AnalyzeData. So it's for the lag between the OpenSIPS and AnalyzeData. And I'm not sure if the HAP covers everything, but an advantage would be then automatically there are a lot of SIP entities, SIP applications which are already implementing HAP, okay, yes, for other purposes, but it's there.
So the response I have is quite a bad one there. So the question is, why are we using this integration rather than the HEP integration that they also offer? So I believe that this is kind of like a legacy kind of thing that we started developing this, and then the 2.4.6 version where we had a bug with the mod promiscuous. Then I think that was the reason why at some point we started fiddling around in 3.0 and we couldn't get it to compile there back then, I believe. So this is something that the HEP solution is something that is very high on our Christmas list. We really want to, indeed, like you say, to make this integration, but it's like a legacy thing that we're still not supporting it that way. But it is, again, it's high on our Christmas list.
Good, good, good. So after Bogdan stole my first one, I will have another one. Would you consider, or are you working on when doing asynchronical monitoring? So don't delay the call, but if we see that we let a malicious call come in, then ending it up with the great call API that we were all introduced today.
Yes, exactly. So, so as my colleague mentioned, we offer two kinds of integration. So one is synchronous and one is asynchronous. So the asynchronous one will actually give you a callback, and then the end user, like our customer. So we we don't manage the OpenSIPS servers ourselves, right? Our customers do. And in that sense, the customer from this webhook is then indeed free, as you say, to terminate that call. Actually, we recommend this. So the reason why we offer this asynchronous variant is that it's usually quite scary for new customers to say, sure, be in line, be in the critical path of my application, and actually block calls for me. They want this two-phased approach where, yes, we're alerting them, we're giving them the button to press, but they want to be the one that actually presses the button to kill the call. So one of the future things that we're indeed envisioning is actually to take this API integration and merge it into our platform. That's so when you're actually in this alert overview, you'll actually get a big red button saying, okay, actually go and fire at OpenSIPS and make OpenSIPS terminate this call for me, like live there from the dashboard. So yes, we are definitely considering this. And again, this is on our Christmas list, but maybe not quite as high as HEP, but it's still on the Christmas list.
Thank you very much. Thank you.
Great. Thank you for the
question.
question.
Look like a great product.
Thank you. Are there more questions? So I think we have like
there was another question from Gary. He was wondering what type of deployments you support on-site or in the cloud.
So at present, all of our stuff is in the cloud. It's Kubernetes based. So we do intend to start supporting on-site deployments. Because, so again, it's Kubernetes based, right? So as long as you run a Kubernetes cluster, you're able to deploy to your Kubernetes cluster. So I'm being okay. So
we can do a quick question here. Morris is saying that the OpenSIPS fraud detect module works great, detects based attempts and call duration, and rejects calls detected as fraud. So no call will complete, but those allowed on fraud detect table. Maybe he's asking if there's some type of integration possible with the fraud detect module.
So I'm kind of going out on, so I have to forward this one to you guys again. So they're asking whether how well we integrate with the OpenSIPS integrated fraud detection module. So in that sense, so again, I'm going to look at you guys.
At this point, we didn't look into the fraud detection as we mainly wanted to get traffic into the AnalyzeData platform. Obviously, this could go together. You could make a multi-layer approach with the fraud detect module from OpenSIPS together with AnalyzeData solution or your self-developed or other external IDS. You can layer all of those approaches, I think.
But so in your question is, are we integrated with that module natively? No, we are not. So that might be something for us to definitely consider.
They are, even if, on a first look, they are, in terms of purpose, quite similar. I would say there are some radical differences between the two. First of all, it's about how you define what is a fraud or not. With the fraud detection module in OpenSIPS, you create profiles and you put like basically static data. What
right.
means,
it's mostly rule based, I think, right? From
it's not necessarily because it's rule, but you have to populate it by basically to upload such information, like what means illegal destination, or what means too much traffic and stuff like that. So it's not learning based on the user dialing pattern. So
one of the things, if I sorry for interrupting you. So one of the things that we are investigating is because, again, we're like, our anti-fraud is broad. Some of the stuff that we're doing in other areas is where we actually integrate in that sense with those existing anti-fraud solutions by populating rules like that. So one of the things you might imagine is indeed, like, once you've learned a profile, that we from the dashboard can automatically populate your OpenSIPS fraud detection module with these rules, like, okay, these are destinations. Once these euro thresholds hit, when you see this, then start blocking in line. That is definitely a possibility. If I may still, like, before, probably there's more questions, and like, again, if there are questions, like, please drop them in the Slack. We'll try to get back to all of you. I want to just continue my 2 slides before I get before I get yelled at for forgetting to do 2 slides. So one of the things that we're doing indeed is trying to tackle this SIP fraud, but there's a bunch of stuff that we're struggling with as well as a startup. So one of the major things is finding people who like larger companies that want to try our solution and actually see, like, okay, can we also in a bigger context rather than our small pilot customers? Can we detect fraud and counter fraud there accurately? So this is kind of like a shout out. Like if you are working at a company who is struggling with fraud, like please hit us up and let's see if we can do something together. So we have a survey with a bunch of questions that we set out. So I'd like to point out to that again with a bunch of stuff that we want to know from you as an OpenSIPS community, as people working in the SIP community. What are your opinions on this? What do you think about this? Are we on the right track? Are we not on the right track? One of the things that we're struggling with is that we have all these algorithms. We're spending a bunch of time on this. Like, what is a reasonable pricing model for us? Is it like one-off? Is it viable to do like volume-based pricing? Like, I'm not sure how familiar you guys are with Sentry, but it's like, okay, we ship stuff to you, and for like a minor, like a thousandth of a cent per call, we'll tell you whether it's fraudulent or not. Is that stuff you would consider? So we would really, really appreciate it if you guys would fill out our survey and questionnaire. And for the people that do, again, we are willing to analyze the 3 months of your CDR for free, just to see like, okay, how much fraud are you actually suffering? Like, so if this is something that you're struggling with and just wondering like, okay, how well is my fraud detection doing? Do I even have fraud? Like, if you're interested in that, hit us up. If you fill out the questionnaire, we'll do 3 months of analysis for you for free.
It's like 4 billion CDRs.
Sorry? So yeah, so one of the ways is,
billion CDRs.
I'm sorry, you dropped out for me. Could you repeat the question?
Like 14 billion CDRs.
Yeah, 14 billion is a little bit much, maybe, but sure, we can always try. Like, we'd be really interested in seeing how far we get, actually, to see how scalable this solution is. So one of the things that we're able to do, we're either able to do 3 months real time or like a one-off CDR. So 14 billion might be a bit much. We can always try and see how far we get. But yeah, so again, we'd really appreciate any feedback you guys have on this.
That's about 15 minutes of Max's like platform. You know that, right?
I don't know, but yeah, we'd be interested. So like, even if we don't do the entire platform for a while, maybe we should like rephrase it and say, okay, it's not 3 months for you, it's 5 minutes, but we'll see. Like, definitely, if you're interested in this, please hit us up. Like, we'd be interested, really.
No, absolutely, we'll talk.
Awesome.
I think you're going to get a lot of queries from a lot of people that were here today.
Yeah, please. So we're actually looking at the Google form live, and we're already seeing like a couple of questionnaire entries coming in. So thank you guys very much for those that are filling that out right now. Definitely. Sorry for interrupting you. No,
that's it. Are you guys, that's the end of the presentation?
Yeah, so these are my slides. So yeah, if you guys have any other questions, I think I have 1 minute, so that's a bit short. But again, like, if it's not here, please feel free to hit us up on the Slack, and we'll try to respond to as much as you as we can.
Live questions, anyone? Use the YouTube or the Slack channel. We're warming up the AI for the raffle.
All right, if not, then I'd really like to thank all of you guys for doing such a great job on organizing a digital conference. We were really looking forward to see all of you guys in Amsterdam, but unfortunately not. But I guess as far as Corona-based stuff goes, this is a really good solution to the problem. So, well, thank you guys for your efforts.
All right, everyone, that's great. That's the last presentation for the day.
Oh, wow, we're closing out.
Yeah, we'll be here again tomorrow, though.
Awesome.
And the day after. Did I mention the day after that too?
Yay!